In this video, I'll be going through the question you see on the screen here from the 2023 Leaving Cert Higher Level Maths Paper 2. If you're looking for a different question from this paper, check out the description below. There should be a playlist there. And if you're looking for a different paper entirely, have a look around on my channel. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But we are on YouTube, so take advantage of the features there. Watch it at half speed or double speed, and certainly pause and try the question first. If you find this video or any of my videos useful, I would greatly appreciate a like or subscribe, but what helps especially is sharing it with a friend that might be doing the Leaving Cert this year or next. In question 1, they give us an image of a spinner that I've half drawn here, and they tell us lots of information about it. They tell us there's 12 different segments made around it. 5 of them are €6, 3 of them are €9, and the rest are 0. So if 8 have already been taken, that's 4 of them are 0. So that's the game we have here. You spin an arrow, and if it lands on a number, presumably you win it. They don't tell us what happens if you land on a line, so we'll assume that's not possible. It's a perfect game. The line is infinitesimally small. That's fine. So part A, they tell us Fiona plays this game a number of times. Work out the probability that Fiona gets 6, then 9, then 6 in her first 3 goes. So the probability on her first one being a 6, let's see, 6 is 5 out of 12. So there's 5 6s out of a total of 12. That'd be the probability of getting a 6 if you did it once. Probability of getting a 9 is 3 out of 12. And the probability of getting a 6 again is 5 out of 12. And the probability of doing all of that, each one of them, one after another, you have to multiply these together. So what we're left with here is 5 5s times 3 is 75 on the top, and I guess 12 to the power 3 on the bottom. And that works out 4 decimal places they want. That works out to be 0.0434. That's the probability. If they ask for a percentage, you multiply that by 100. If they ask for a fraction, your calculator should do that out for you. Okay, that's part A. Part B, we're still playing the same game. Ronan plays the game a number of times. Find the probability that Ronan gets 9 for the 3rd time on the 8th time he plays the game. So that's a very complicated one. Let's do it like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so they want the probability that he gets a 9 on the 8th time. So we know the probability of getting a 9. That's 3 over 12, which is 1 over 4. So they're locking that in. They're telling us we have to do that. On the 9th time, we have to get this. And then more information is we have to do it 3 times. We have to get a 9. This is for the 3rd time. So 2 more of these have to be a 9. And what else then? The other important thing is not a 9. We don't care about 6 or 0. So we need to know a 9 is 1 over 4. And not a 9 would be 3 over 4. So let me just put out a possibility that could have happened. He could have got a 9 the first time. That's a 1 in 4 chance. A 9 the second time. A 1 in 4 chance. But we're only allowed to get 3 9s total. So the rest of them would be, say, 3 over 4, 3 over 4, 3 over 4, 3 over 4, and 3 over 4. This is the probability of getting the 3rd 9 on the 8th time. Except not quite. Because it's also possible that it wasn't the first 2 was a 9, maybe the 1st and the 3rd, and there's a lot of combinations here. So we can work out this probability first if we want. We can work out this probability as 1 over 4 to the power 3. That's all those 1 over 4s times 3 over 4 to the power of how many's left over there? Did they say it's an 8th time? There's 7 of them. 7. There's 5 of these, isn't there? Clean all this up. I guess we get 3 to the power 5, 4 to the power of 8, and we won't work out the percentage for that because it's not the full thing we want. What we need here is how many different ways we can get 2 into these 7, and hopefully you probably get it from what I said there. But let's look at it this way, because we can actually just count them all up. We could have the 2 9s here. Let me use both hands for this. 2 9s, that's one way. 2 9s here, that's 2 ways. 2 9s here, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. There's 21 different ways to do that, and you could count that in your head if you want. That means the probability is this number multiplied by 21, and that'll give you your full marks. You don't have to count 21. If this number was like a million, you couldn't have done that. So this is also, let's say, 3 to the power 5 over 4 to the power of 8. It's 7 choose 2, because that's what you're doing there. You have 7 spots, 2 things can go, and there's how many different ways that can happen is 7 choose 2. So whichever way you got that 21, that's what you need to do. Put all that into a calculator, and I think this is the answer here. 0.0779. They also wanted 4 decimal places. Question C, there's a nice trick in question C I'm going to show you. But the question is, Olga plays the game twice, just 2 times, and find the probability that she gets less than €16. Whenever you're asked, here's the trick, I'll give you the trick up front. Whenever you're asked to find something less than something, it's sometimes helpful, and in this case it's sometimes helpful to think of finding more than it. So instead of finding less than 16, if you found more than 16, those answers should be connected. In this case we're talking probability. So if there's a 90% chance of finding less than 16, there's a 10% chance of more than 16. So you can choose which of them to solve and just take one away from the answer, or the answer away from one. And that's what we're going to do here. Let's see, she only plays the game twice, so I can write out every possibility, every possible outcome to this game. She could get 0 and 0, she could get 0 and 6, 0 and 9, that's all, isn't it? 6, 9 and 0. She could get 6 and 0, 6 and 6, 6 and 9, or she could get 9 and 0, 9 and 6, 9 and 9. They're the only outcomes that could happen, but we're talking about the total money. So 0, 0 would, let me do another 3 by 3 box. 0, 0 would get 0, 0 and 6 would give me 6, 0, 9 be 9, that'd be 6, 12, what's that, 15, 9, 15 and 18. So these are the only outcomes that can happen to playing the game twice. And the interesting thing is the probability of getting less than 16. Well, all of them are less than 16 except for one guy. This is more than, and this is less than. So you have a choice here. You can work out the probability of getting all 8 of these and add them together. That's a perfectly okay thing to do, and it won't take you that long. Some of them are similar. It'll be fine, don't worry. But the much easier answer is, let's find out the probability of getting this, because we can easily then find not this. So the probability of getting a 9 and a 9 is 3 over 12 times 3 over 12, which the answer is 9 over 144. That's the probability of getting more than 16, or 18 in this case. So the probability of getting less than 16 must be 1 minus 9 over 144, which would equal, what would that be? 135 over 145. Put that into a calculator. And did they ask for it? Yeah, decimal places. Put that into a calculator and we get 0.9375. So quite a high. Remember, a probability of 1 is guaranteed. Quite a high probability of getting less than 16. Okay, that's it for question 1. Thank you for watching. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Have a great day.